Section 3-5 is parallel lines and triangles. So we have a few theorems. Actually, we're going to start with the postulate. Postulate 3-2, let's put a colon there, is the parallel postulate. Through a point, not on a line, there is one and only one line parallel to the given line. So through a point not on a line, first we have to have a line and a point not on the line. Through this point, I'm going to call it P, there is one and only one line parallel to the given line L. In other words, if I draw another line through P, I can draw lots of lines through P. I could draw this line, I could draw this line, I could draw this line, but only one of those lines is going to be parallel to the given line. So that's our parallel line postulate. Theorem 311, triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. So if I have any triangle and I have angle A, B, and C, the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. So we're going to take a minute and prove that. So given triangle ABC, we're going to prove that the measure of angle A, and you'll see what angle 2 is in a minute, angle 2 and angle C, well actually we'll label it now, equal 180. So proof. First thing we're going to do is draw line PR through point B parallel to AC. And I can do this by the parallel postulate, which says that there is one and only one line passing through B, that is parallel to C. Sorry, that didn't come out very good. Let me see if I can fix that. Okay. Through B, parallel to AC. And I'm going to call that line PR. And I'm going to label some angles here so that I can use them. So that's the first thing we're going to do. We're going to draw this parallel line. The second thing we're going to do is we're going to say, that angle PBC over here, and angle 3 are supplementary. And I can do that by the postulate that says that angles that form a linear pair are supplementary. Number 3, I'm going to say that the measure of angle PBC plus the measure of angle 3 equals 180. You probably know what that is now. That's the definition of supplementary angles. Number 4, I'm going to say that the measure of angle PBC equals the measure, PBC equals the measure of angle 1 plus the measure of angle 2. That's one we haven't used in a while, but that's the angle addition postulate. Angle addition postulate. Okay, 5. So now I've got 1 and 2 and 3 equals, or 1 plus 2 equals PBC, and I've got PBC plus 3 equals 180. So let's see. Measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180. I substituted in place of PBC my equivalence, so that's straight substitution. Okay? Number 6. Angle 1 is congruent with angle A. Sorry. And angle 2 is congruent to, angle 3. Did I do that right? Yeah, angle 3. Sorry. Angle 3 is congruent to angle C. So take a look at these. Remember, the top line and this line are parallel. If I look at the left-hand side as a transversal, 1 and angle A, which is the angle inside the triangle, are alternate interior angles, as are 3 and C. So number 6, if two lines are parallel, which we know our lines are, then alternate interior angles are congruent. All right. Angle 1, the measure of angle 1 equals the measure of angle A, and the measure of angle 3 equals the measure of angle C, and that's again congruent angles have equal measure. And number 8, I'm going to now do some substitution. Back into this line, and I'm going to say the measure of angle A plus the measure of angle 2 plus the measure of angle C equals 180. And that's what I had to prove. So that's substitution. Okay, so we've just proven that the three angles, and you notice that we took angle B up here and renamed it, because as soon as I put the parallel line, I had more than one angle with a vertex of B, so I had to name it something else. But we've basically proven that angle A plus angle B plus angle C equals 180. Okay? So using that, can we find the values of x, y, and z? Take a minute on your own and see what you can come up with, and pause the video and then come on back and let's see if we got the same answers. Okay, so I started with this left-hand triangle, and I said that 43 plus 59 plus x equals 180. That gives me 102 plus x equals 180, and x equals 78 degrees. Then I went to x and y, and I said x plus y have to equal 180 because they form a linear pair. I already know that x is 78, so therefore y is 102. Then I went to the right-hand triangle. 49 plus y plus z equals 180. I know that y is 102. So that's 151 plus z equals 180, and z equals 29. So we can use that as one of our ways of solving for an unknown angle. Okay, a couple of quick definitions. An exterior angle of a polygon is an angle formed by a side and an extension of an adjacent side. So any polygon, let me go back to my white. Okay, so any polygon, if I take a side, let's say this one here, and an extension of one of the adjacent sides, if I extend that, this is my exterior angle. My next definition says for each exterior angle of a triangle, the remote interior angles are the two non-adjacent interior angles. So here's my triangle. I'm going to extend one of my sides to get an exterior angle. So the remote interior angles are the two non-adjacent, not adjacent to my exterior angle, of interior angles. So this exterior angle x has remote interior angles in these two positions. Okay, so let's see what we want to do with this. Theorem 312, triangle exterior angles theorem. The measure of each exterior angle of a triangle equals the sum of the measures of its two remote interior angles. So I've written one exterior angle here, number 1, and it equals the sum of 2 plus 3. I don't want you to do a formal proof, but I'd like you to think and jot down in just a few sentences as to why that is true. And we'll talk in class about why that is a true theorem that could have been proved. We're just not going to take time to do it. So, whoops, let's go back. So, for example, if I have this, well, come on. If I draw this triangle, and I tell you that I want to find the value of this exterior angle, and I tell you that this is 60 and this is 35, you can tell me that x equals 60 plus 35, so x is 90 degrees. Also, if I have something like this, and that's 120, and I tell you this is 50 and this is x, you can solve for x by saying, whoops, x plus 50 equals 120, so x equals 70. Pretty simple. All right, and that's it for this lesson. Well,